So now, having seen all of that, let's see what kind of steps that we can take to actually improve the Wi-Fi within our condos. And the first thing in the plan is to remove unnecessary routers. Now's a good time if you are planning to completely cut off your Comcast signals in particular. Please do so and have those routers removed, and that solves some of the interference problems right there. Uh, the main thing is to use the assigned radio channels only. Uh, by doing that, we eliminate interference from nearby Wi-Fi access points. And then the next action plan is to eliminate interference sources. We'll look at a list of those in a bit, but basically we want to get rid of things that may be interfering with Wi-Fi that are not Wi-Fi devices themselves, but they can interfere. Now, the primary focus of this evening's presentation, though, is to use the Wi-Fi channels that are assigned only. For those of you that have the Ubiquiti, the standard Spires net access points installed, you don't have to do anything because these use those assigned radio channels. That was done as part of the project. For those of you that continue to use other Wi-Fi access points, routers, Comcast or otherwise, it's important that you change your radio channels to the assigned channels. That'll help you and it'll help your neighbors. The next thing that can be done is to relocate the access point. I had just shown the signal strength that occurs in going from inside the closet to outside the closet. The big advantage of getting outside the closet is that 5 gigahertz radio can cover most of your space if you're outside the closet, particularly in the larger condos. In the smaller condos, it's less of an issue. But by doing that, you can primarily use the 5 gigahertz channels, which is not subject to very much interference. Some additional things that you could consider is actually having some wired connections, and this might make sense for stationary devices, that is your desktop PCs and televisions. And that can be done directly with an Ethernet cable. It's also possible to use your coax cables, your regular TV cables, as a secondary network within your unit. And it's also possible to send the signals over the electrical power in your unit. We won't talk about that in any detail, but I want people to understand that that's a possibility, and we could discuss it on a one-on-one basis at a later time. Now, one thing we want to alert you to in terms of these channel selections, don't use automatic channel selection. And the reason is that every time that a router, the general way it works, every time a router starts up, for example, after a power failure or some reset that you've done manually, it takes a quick look at the Wi-Fi signals that it sees in the area and chooses a channel that doesn't have much Wi-Fi, very strong Wi-Fi signals on it. However, these can really get fooled because they take a very brief snapshot. And in fact, imagine if you had a power failure within the building and everybody's Wi-Fi is coming back to life at the same time. And automatic channel selection just wouldn't have a clue of what's going on. What we've done, because we know the geometry of the building, by having the channels properly assigned, we can eliminate the randomness associated with automatic channel selection. Another problem with automatic channel selection is that there are some 5 gigahertz channels that are allowed that I haven't talked about today, and sometimes you could operate on that. However, if that access point observes a Doppler radar signal coming in on that same channel, it's forced to switch, and then it'll switch back to one of the channels that we're using, and may well end up being a major source of interference for your neighbors. Also, don't use the wide channels in the 2.4 gigahertz. So it's possible to take, rather than one channel, to have a Wi-Fi signal that uses two channels in the 2.4 gigahertz space. Doing that is really like trying to hog two elevators in our four elevators. You wouldn't go out and press the buttons going up and down on the regular elevator call buttons as well as the service elevator. You could end up commandeering three elevators out of four by doing that. The same idea exists for the 2.4 gigahertz wide channels. On the other hand, the 5 gigahertz, we do have it set up to use multiple channels at the same time because of its nature. That works very well. Other thing I would suggest is that you avoid direct printer connections. So I mentioned there were 25 printers that seem to be broadcasting their own Wi-Fi signal. My recommendation would be to have those connect directly to your Wi-Fi access point and not be their own broadcast station. That will eliminate a source of interference within your unit and let your Wi-Fi access point be the common point of operation for your Wi-Fi signal. Now, we'll finally get to the ugly part. And I don't want to make this sound too negative, but there is an ugly part. That interference that we saw back on our quaint little one-lane bridge kind of comes in two modes. The motorcycle here represents the Bluetooth type interference, signals that are intended to run in the same frequency space as Wi-Fi. The FCC allows that. The other interference is uglier, and it's things like microwave ovens or other electrical devices that really just shouldn't be interfering, but in fact they really do. Microwave ovens in the 2.4 gigahertz space are a significant cause of interference. Fortunately, that doesn't last for very long. They typically run for a minute or 5 minutes, so it's not like an ongoing thing. Cordless telephones can be either in the 2.4 or 5 gigahertz frequency space, and they can be a source of significant interference. I think especially some of the older 2.4 gigahertz phones can really wreck a Wi-Fi signal, depending on the location. If they happen to be right near your Wi-Fi access point or near the device you're trying to use, they can really mess up the signal. Security cameras that non-Wi-Fi cameras, that is cameras that produce a continuous signal. Some baby monitors do this, and some other security cameras that have their own radio signals but are not Wi-Fi signals can cause significant interference in your signal, and it could come from your unit or from neighboring units. The Bluetooth speakers, mouse, and so forth, those do interfere a little bit, but in fact they're usually fairly low powered and they don't use up too much bandwidth, so they're not a big problem, but they can contribute to this overall interference. Zigbee is another standard I suspect most people haven't heard of, but it's used kind of for the Internet of Things. If you have a so-called smart refrigerator that connects to the internet, or it could be your dimmer switches or automatic lock. Our electrical meters, I believe, communicate through Zigbee. These are signals somewhat like Bluetooth, but you have enough of those around in the space, and that adds to the kind of the Wi-Fi interference that slows down your intended Wi-Fi conversations. Motion detectors can also do this, and in particular, some motion detectors that send out a signal in the 5 gigahertz band. They're like a little radar detector, and these can be a source of significant interference with a Wi-Fi signal. And that can be both the 2.4 and the 5 gigahertz. Other things, some LED lights. Can you imagine that these things can be sources of interference? Now, they're not supposed to be. They're supposed to be shielded such that they don't let their interference signal get out. But in fact, some poorly shielded lights, faulty fluorescent light ballast, and other kinds of electrical devices that are not supposed to interfere in this space, in fact, sometimes do. And then there's a laundry list of devices that may well interfere. The ones that I've listed here are ones that I think are well established. There's others that may be a wives' tale, but in fact, they can exist for sure. In my own experience, since I kind of keep track of signal interference, most of the time in my space, things are pretty quiet. But once in a while, it seems like everywhere around my space or other spaces, there's a high level of interference. And it's coming from sources that I cannot identify.